Jade, and he's going to tell you everything about Jade and everything you didn't know is going to be revealed today. So, have a mic.
Thank you. Okay, so I'm going to be talking about Jade. A quick show of hands, just to start off with, who's used Jade? Wow, that's like half of them. That's way more than expected. The rest of you then, who's heard of Jade? Before this talk, obviously. Okay, that's so most people have heard of it. So I'm going to run through this very quickly. Jade is a templating language, it uses HTML, usability, and all that sort of thing. It lets us take an HTML template like this, drop the end tags, drop the angle brackets, and we have something a bit cleaner and neater and tidier. But more than that, it has lots of advanced features. It supports inline HTML, it supports buffering output, both unescaped and escaped, so that you can keep everything safe from cross-site scripting attacks and that kind of thing. It supports attributes, and the attributes can have dynamic values via JavaScript expressions. It supports interpolation, so you can have JavaScript expressions in the middle of some string of text, and these get evaluated. Some of you might not have seen this. You can have inline Jade inside a string of text. So in this example, we've taken the paragraph tag at the top. We've marked it with a dot on the end to say the entire body of that paragraph is just plain text. There's no Jade, there's no markup in it. But then we can use this hash followed by square brackets to indicate that there's some nested Jade inside that, which is useful for inline tags like strong and anchors and code and things like that to put those inside your long strings of text without having to break that out into lots of separate lines and make things complicated. So anyway, we have that feature. It supports loops and conditionals because it's a full dynamic templating language, so you can do all of that sort of thing, if, else, each, etc. We even support custom JavaScript, so you can mark a line as JavaScript by putting a dash at the beginning of it. And we support splitting your templates into multiple files, so you can use include and give it a string to another, that's a path to another file, and that will get kind of loaded in and inlined inside that JavaScript file. And we support mixins, which are kind of like just some syntax sugar around a function. So they let you wrap up a bit of HTML as a function that takes some arguments, and then reuse that throughout your code. Mixins can have bodies. We do inheritance, so again, if you're splitting things up into multiple files, for a project you might have a layout file that has the headers, the navigation, the boilerplate HTML stuff like links to style sheets and script tags and your doc type and all that kind of thing. And it can define various blocks, like in this example we've defined a title block and a content block. And then for your individual page, you just say, we extend this base template and we override this block and we override that block. So that's inheritance, that would render this template. So there's a lot of slides here because I just stole those off of an intro to Jade talk. So the interesting bit and the bit why we'll actually hear is how does this work under the hood? What is Jade and when you peel the covers off? So Jade is a compiler. How big is that? That's quite small. So I did open it earlier here. Cool. So that diagram behind me shows you essentially how the Jade compiler works. This is how pretty much all compilers work approximately. So there's Alexa, and Alexa takes a string of text, in this case our Jade source code, and it tokenizes that text. So it takes a string of text that might have tag names and attributes and strings of JavaScript expressions in it, and it converts that into a stream of tokens where each token represents some kind of complete chunk of the source code. So a whole tag name or a whole set of attributes or a whole JavaScript expression rather than just a single character, or rather than just being a stream of meaningless characters, it gives it that definition as to where where each token begins and ends. That token stream is fed into the parser, and the parser reads in those tokens one at a time and converts it into something called an abstract syntax tree. Has anyone knows what an abstract syntax tree is? Cool, so about a third of you. So an abstract syntax tree, it's a representation of the program, of the computer program. So it's kind of what you think about in your head. So if you take, say, a mathematical function that's like 5 plus 10 times 4, then the abstract syntax tree of that is the plus operation with on one side the 5 and on the other side the 10 times 4. So that abstract syntax tree is a much easier representation of our program to use internally in the compiler infrastructure. So having generated that, we give that to what we have confusingly called the compiler. It's as part of the Jade compiler. There's a project called the Jade compiler, but inside it has a thing called the compiler. But really, we should have called that the code generator to fit in with the terminology of compilers in general. It takes the abstract syntax tree, it looks at each node as it goes down the tree, and it produces a JavaScript string out. We then evaluate that JavaScript, and that produces our HTML that we can send to the client and render in the web browser. So I'm going to go through each of these components in a bit more detail. So let's go back to the slides. So the Lexer. The Lexer reads the input one character at a time, as I've said, uses lots of regular expressions, and it breaks that stream up into separate tokens. And those tokens look something like, so if we imagine this input jade file, so it's an anchor tag that has an href property set to URL and a description, followed by a paragraph with a strong tag that contains some plain HTML. Having passed that through the Lexer, we get this stream of tokens. So that is a token that represents the tag, which is marked as not being self-closing, and has a value of A for anchor. And then it's followed by a token that represents the attributes, which has this array of name, value, and whether or not it's escaped. So whether it should be escaped to prevent cross-site scripting attacks or not. And so on all the way down, you can see this is a stream of individual tokens. Each line of this file represents a token. Okay. So then internally we use the character parser. So this is there really just to handle the intricacies of the fact that Jade accepts JavaScript expressions within the source code. So to do that, we need to be able to tell when a JavaScript expression starts and when it ends. So say we've got a JavaScript expression that's in brackets. Character parser allows us to extract just the portion within the brackets and ignore things like open brackets and closed brackets that are in quote blocks, and also track the number of open brackets and then the number of closed brackets, so that you can, for example, call a function within an expression that we know is in brackets, and that the closed brackets from the end of your function call won't cause Jade to think you've ended the expression early. So the character parser takes a JavaScript file and essentially allows you to tokenize it or parse it one character at a time, and then stop once you're no longer interested, which makes it very useful for looking for JavaScript expressions within files that might be written in another language that isn't JavaScript. So the next step, once we've got those tokens, is that we parse them. So we read in a stream of tokens from the Lexer, and we construct a tree to represent the abstract logic of the template. So if we take that same stream of tokens, so we feed this stream of tokens now into the Jade parser, and we will get out an AST, which I have prepared earlier. So this is the abstract syntax tree. It starts with a block at the top level. A block is just saying there are multiple nodes in this, and then we have a node for the type, for the tag, which has a type of anchor, and note that rather than just saying there's a tag followed by some attributes, followed by some body, we're now saying the tag has a property, attributes, or actress for short, that has this attribute which has name, href, and val of URL. And then going down, we've got, this is the body of that attribute, of that anchor tag in code. And then we've got the paragraph tag, and inside that it has a block which contains the strong tag. So if you just come back to the attributes jade, you can see that's a paragraph containing a strong tag containing some text. So that abstract syntax tree represents that structure where the tokens don't really represent that structure. But our parser has some slight oddities. So the current jade parser also is responsible for loading. Can you hear me? No, it's gone. Is it back now? Okay, I might have accidentally pressed the button on the bottom. Okay. So the parser has some slight oddities. It reads in, it's responsible for reading in files because, as we said, we can split our jade files into, our jade templates into multiple files using include and extend. So it has to read in those files, it then has to recursively let and parse those files, and then it has to do the linking of those files. So it takes the, so say you've got a template that extends some other template and it overrides some of the blocks in the layout template. You have to, this parser is responsible for reading and lexing both files, reading and lexing and parsing both files, and then linking them together and figuring out which blocks override which blocks in the child override which blocks in the parent, and then producing some overall abstract syntax tree of the whole collection. And this turns out to be one of the most error-prone, complex parts of the jade parser's process. So, that's how jade 1.0 works. Jade 2.0 should be out any day now, once I finished it. It's really very close to ready, I just haven't pulled the trigger yet. And jade 2.0 works slightly differently. So if we revisit that diagram of how the parser works, and I'll just shrink this down so it fits on the screen. Okay, so we've changed things slightly in that we've created this new thing called a loader, which takes the lexer and the parser and joins them together, and it's responsible for that recursive process of loading files in, lexing them and parsing them, and then finding out all of their dependencies and then loading all of those dependencies in and lexing and parsing those. And it's just responsible for that purpose, for that process. It doesn't attempt to link them together, it doesn't attempt to figure out which blocks override which other blocks, and it doesn't attempt to do the lexing or parsing itself. It delegates that process to other modules. So that makes it relatively simple as a module. All it does is walk the abstract syntax tree, figure out the dependencies, read them in, lex them, parse them, and repeat. It also means that if you wanted to, say, build a version of the Jade compiler that loaded in files asynchronously rather than synchronously using read file sync, you could do so simply by replacing this loader component with an asynchronous loader. We then have another separate set that takes that abstract syntax tree, or that collection of abstract syntax trees, I should say now, that has both the original targets that we asked it to compile, and also all of its dependencies and all of their dependencies. And those have already been parsed and lexed and dealt with, and it's just responsible for linking them together. So the linker is the bit I'm currently working on writing. It is one of the more complicated bits of the Jade parser, the Jade compiler infrastructure, but it is at least completely separate now from the rest of the Jade infrastructure. So it can be unit tested, it can be carefully designed, we can try rewriting it several times if we want to, and plug different versions of it in and see what works and what doesn't. a lot more easily than with it, just with that logic just sort of hidden in amongst the parser. So that's where we're going with that. And then the rest of that pipeline is the same. So the loader, again, it's going to load in files via fs.read file sync. It's going to lex them using the lexer. It's going to parse them using the parser. The linker takes the abstract syntax tree with the dependencies just kind of linked in, but just attached to the nodes where those dependencies are loaded in, and then it does the linking process. We then come to the compiler. The compiler takes an abstract syntax tree that has already been linked, it's already had that stuff dealt with, and it just has to generate JavaScript code that pushes HTML strings into a buffer array and then returns those. So we can see an example of the type kind of JavaScript that it generates. So if we come back to this example, then it produces JavaScript code that looks something like this. So it produces a template function. We can ignore the mixins variable because we're not actually using any mixins in this example. So it creates this template function that takes some locals, some data as input. It's then going to load each of these variables in and pass them to this child function. So in this case, it's loading locals.description and locals.url in here. And then it's going to push that anchor tag into our buffer as some actual strings with the attributes inline in there as additions. And then here we can see it doing some escaping, so it's saying if the description is equal to null, then just use the empty string, otherwise use the description, and then having done that, it's going to escape that description so that we don't allow any cross-site scripting if that description comes from a user, say, and then it's going to put that out into the actual string. And then for the example of where it's got a paragraph with a strong tag, it's figured out that there's no dynamic stuff going on inside those. We've just given it some plain jade with no JavaScript stuff in it. So it will have done that at compile time, it will have fully processed that, and you can see here that all of this paragraph containing a strong, containing plain HTML as text, has just been put in as a string. So when we're rendering that template thousands of times a second, because our web app has become hugely unexpectedly popular, we can keep rendering this really quickly because we're not having to do any string concatenation or anything there, we're just pumping that string straight out. And then at the bottom, we join the buffer together with the empty string and return the result. And that's all that's going on there. So that's the compiler. The compiler delegates some stuff out to Jade runtime. So Jade runtime does things like escaping the JavaScript expressions to remove things like the open angle brackets from code submitted by users. It handles joining class names together, so you can use an array in the classes attribute, and it will join those together with spaces. You can equally use an object instead of the style attribute, and it will figure out how to make that into a sensible string to use as a style attribute in the HTML. It handles error reporting, it does all of that kind of stuff. In Jade 1, this has to be loaded in separately, so there's a Jade runtime, there's a runtime.js file in the root of the Jade GitHub organization, and if you're using Jade client-side, so you're pre-compiling it on the server, but then you're sending that compiled function to the client to be rendered, then you have to include that script tag on every page. In Jade 2.0, we're looking at possibly having the compiler just inline the methods it needs from runtime, because typically there aren't very many of those, so it wouldn't actually be that expensive, and it should make the process of using the Jade compiler, particularly with client-side code, a lot easier. Another thing that the Jade compiler, the code generation stage uses is a module called Constantinople, which parses JavaScript using Acorn. It then uses a module called Acorn Globals to establish all of the global variables that exist within that function, and it also treats this as a global variable for the purposes of this experiment. And if that list is empty, then we know that the code that we're looking at must be a constant. Because if you don't touch any global variables, and we're including things like math.random is still a global variable, date is a global variable as far as we're concerned. So if you don't touch any of those, then your code must evaluate to a constant every time it's run. So by checking for all of the global variables and finding out that there are none, we can then evaluate that code, produce the results, and then turn it back into a string and put it in a template. And that saves you, so if you want to, you can write such and such an attribute equals 40 plus 2, and the 40 plus 2 will actually happen at compile time, and then the checking that 42 doesn't have any angle brackets in it or ampersands or whatever will also happen at compile time, and then what will end up in your resulting JavaScript will just be the string 42. So it's an optimization that turns out to be, in practice, pretty useful. We also use a module called with. So many of you will be familiar with the with operator in JavaScript. It lets you take an object and kind of expose that object's properties as if they were variables for some bit of code. So in this example, the code you see at the top, the first of these two code samples, the foo and the bar might be coming from the object. So what you can do is feed this code into the with module, and it will extract those properties and into local variables for us. And it actually produces slightly more complex code than this because it will handle the case where that property isn't in the object and look for it as a global variable instead. But for the purposes of explanation, it's roughly like this. And the advantage of doing this at compile time rather than just using the with construct at runtime are twofold. One is that with is a strict mode violation, so if you want your code to have use strict at the top of it, then you cannot use with anywhere inside that code. And the second is that there's a good reason why it's a strict mode violation, and that's that it incurs a massive performance hit. So we're talking something of the order of 20% performance hit on the compilation, on the rendering at time of a jade file. That's a pretty significant improvement if that happens to be a bottleneck of your application. So that's why we do that at compile time. So I want to have a little bit of a sidetrack now. A specific feature of Jade, which is filters. So filters let you write code a bit like this. So what I've done here is I've said, I've got a Jade template, somewhere in the middle of it I'm going to have some markdown. So I tag that code as markdown, and then it gets compiled using markdown, using a markdown library like marked or markdown-it or whatever. And then the HTML gets outputted along with the rest of the data. And there's a filter for markdown, but there's also a filter for CoffeeScript, to compile CoffeeScript to JavaScript. There's filters for just about every templating language out there, so you can have a little underscore template in the middle of your Jade template if you want to. There's even a Jade filter, so you can have some Jade inside your Jade template and kind of go all meta. And I don't think it works brilliantly as a solution, but it's a bit kind of hacky, and it's probably not worthwhile, but it's an option, and you can do that kind of thing. So there are about 30 of these filters, 30 or 40 of these. And as you can imagine, I don't want those 30 or 40 separate filters to live as code inside the Jade organization, so inside the Jade repository. So I created a separate module to handle this problem for me, and it's called Transformers. It creates a common API for all transformations that take a string and some data and output a string. So that's virtually all compilers, but that's also all templating engines you can think of. It's the less Sass and Stylus, those sorts of languages, Markdown, etc., all take a string and some data or some options or something, and then output a string. So Transformers has this collection of 30 or 40 of these that we can just use, and you can see an example of how you would use a transformer from the Transformers library in there. Now, there are two slight flaws with the Transformers repository that I didn't really fully register until I built most of it. The first is that it doesn't include the modules that are needed for the transformation as a dependency. So obviously, with 30 or 40 of these transformers, I didn't want to have the Transformers module require you to install 30 or 40 dependencies when each of those dependencies are things like CoffeeScript and what have you. And they're relatively large downloads. They're probably unnecessary for the project you're building because just because you're using Jade, there's a good chance you're not using CoffeeScript. So making you install CoffeeScript seems a bit crazy. So I didn't want to do that, so it doesn't include them. The downside is that somebody releases a breaking change in the less compiler, and you depend on transformers and you depend on less so that you can have the less transformer. Then you update less, and all of a sudden you can no longer use less with transformers because transformers was targeting the old API of less. And this is something we've had this problem. It is currently still the case that if you want to use the less filter in a Jade file, you have to install an old version of less in order for it to be compatible. And then this problem is exacerbated by the fact that Transformers is one large module with these 40-odd separate transformers in it, each of which has to be released as one homogeneous mass. So when I make a breaking change to one transformer, because I follow Sender, I have to update the major version of the whole repository. So then when I make a bug fix in one of the other transformers, nobody can have that bug fix until they also accept the breaking change in a separate transformer that they might not even have been using. Because of the way that Jade uses transformers as a dependency, if Jade ships a version of transformers with a breaking change, then that's a breaking change to Jade. So we end up with this cascade of breaking changes that probably nobody cares about, but that because we're following strict Sender, we have to report. So there has to be a better solution, and here it is. So I started the JS Transformers organization. Goal is very similar, creates a common API for all string and data to string transformations, although we're going a bit further here because we're also considering things like Jade, where we're taking a string and some options, and then that goes to some JavaScript code, and then that JavaScript code takes some data, and then that goes to a string. So we consider that use case as well, the compiled views, the compiled templates. As part of that, we allow you to... the end result of this is that we include we publish these as separate modules, one for each transformation. So if you want to use the CoffeeScript transformer, you could go ahead and npm install JS transformer-CoffeeScript, and you would just install the CoffeeScript transformer. You'd only have the code needed to transform CoffeeScript. But on the other hand, you'd have all the code you needed to transform CoffeeScript, including the CoffeeScript dependency that transformer has. Hello? There we go. That button's just too easy to press.
Is it WebSocket, I think?
No, that is just this cable, I think.
Okay.
But I'm not sure what's that.
Freezer is in the room.
That, yeah, because, yeah. Yeah, that's interesting.
Wait, what?
Yeah, I don't think this is my laptop. It's magic. All right.
No more slides, that's okay. We can do it.
Must be running Windows.
I'll try and keep my feet still.
Please don't keep me quick. It's quite expensive, I think.
There we go. Okay. So let's go back to we saw that. Okay. So that's how transformers looked. You load the transformers module. You pull out the transformer with the given name, and then you render it, and you hope that that dependency is installed and has the correct version, and if so, it'll work. Otherwise, it will blow up. So JS transformers looks pretty similar, except that you npm install the JS transformer that you want. That comes with the dependency, and you can just call render on that resulting module. It also has things like compile client in the same way that Jade does. One of the things that's perhaps interesting about JS transformers is that we do kind of extreme open governance for this. So if you contribute to JS transformers, any code at all, anywhere, any pull request, if I merge it, I will add you as an owner of that GitHub organization. And although I haven't yet automated this yet, I plan to also automate something that will npm add you as an owner on npm as well, so you can start publishing and releasing these things, because I do not have time to maintain 40-odd transformers of random different libraries. So get involved, do this. I really, really want more people on this. So if your favorite templating language, your favorite compile to JavaScript language, you use TypeScript and we only support LiveScript, whatever, that kind of thing, you get on this and open an issue, tell me you want to write the module, and you will get added as an owner. That's how we're working this. So, yeah. Okay, so back to Jade now. Extensibility. So Jade compiles to HTML. That's pretty limited, but it's great for server-side stuff. You can use it on the client side because you can run Jade. The Jade command line has a -- client flag to say compile this to some JavaScript, and I'm then going to run on my client. And that allows you to generate some HTML on the client, but it's still just HTML. And if your page is reasonably interactive, then just setting inner HTML on the whole page anytime anything changes is not going to work brilliantly. But Facebook have an interesting project called React, and it lets you generate a virtual DOM and then essentially overwrite the whole contents of the page with a new virtual DOM, and it will do the clever thing of diffing the new virtual DOM against the old virtual DOM, figure out the minimal set of updates and changes, and then apply those. It also handles event binding and all of that sort of thing in nice ways. So React is a great library for building front-end stuff. Jade is a great way of writing HTML, and particularly HTML that has data in it, dynamic HTML. So what if we could join these two things? Well, we have. This is the React Jade project. It's on GitHub. It uses the Jade Lexer behind the scenes. It uses the Jade parser behind the scenes. It uses the Jade loader, the Jade linker, the Jade runtime. It uses Constantinople for optimizations. It uses width. So it's really using 90% of the Jade stack, and that just works. It means that actually React Jade is pretty simple. It really just is its own implementation of the Jade code generator or the Jade compiler. So it's 150 lines of code. It's nothing really, and it lets you take something like this. So given this Jade example where we've got an anchor tag, an href, and then some text in it, rather than generating some HTML, this will generate a bit of JavaScript code that calls react.createElement with a, and then the attributes as an object, and then the body as a string. And you can use this straight away in the React DOM diffing APIs. So, hopefully, those of you who write any code for the client are using Browserify or something similar. And if you're using Browserify, then you can use React Jade in a really efficient way, really out of the box with Browserify. So, as well as using React Jade in your code, if you also set up your code to be compiled using the React Jade transform in Browserify, then you can write code like the top half that just says, like, load React Jade and then export jade.compile file and then some file name. And what that will actually end up as on the client will be exporting a function that returns that react.create element with the, use the same example as the previous slide. So you're then not doing the work of parsing Jade and figuring out what the global variables are and all of that stuff on the client. So you're now doing it on the server side and you're sending highly optimized code to the client. And that's a really effective way of doing these things. The way that React encourages you to work is to keep your markup with your behavior. So you want your, if you're using React Facebook, like you to use JSX, where you put your HTML in your JavaScript as kind of XML tags. So keep everything together. And React Jade lets you do something very similar using ES6 template literals, or tagged template literals in this case. So what you can do is load the Jade module, and then you can do your React.create class. So in this case, I've got a button that says click me, and when you click it, it turns into a paragraph that says you clicked me. So I've created a React class. I've given it an onClick method that sets the state of clicked to true. And then in the render method of the React element, I've just used a tagged template literal, so I can just write Jade code instead of that whole React.create element, blah, 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 blah. Instead, I just have a Jade style if, so if not this.state.clicked, then button with onClick set to this.onClick, and click me as the contents, else load the paragraph. And again, we can run this through Browserify, and we'll get something like this. Approximately. I did this conversion by hand, so it looks a lot neater than the output of the compiler, but the compiler will produce something very similar functionally. So it's just replaced that tagged template literal, which is a multi-line string effectively, with a function that says if not this.state.clicked, then return React.create element button, etc. Now, the interesting thing about this versus JSX is that this is valid JavaScript code. If you run in a modern enough JavaScript environment, like a version of Chrome that probably hasn't been released yet, or say IO.js, then this will just run without any compilation step, and it's valid JavaScript, and it will function exactly the same as this code. So there's the compilation step is just optimization. It's not required to create the desired functionality. So, React Jade is a great example of how you can extend Jade to other scenarios and other situations. There's a project called then Jade as well, which extends it in a slightly different direction towards having asynchronous template rendering. But one of the things that a lot of people are after is, why can't we write ES6 code inside our Jade templates? That would be great, right? Well, first of all, we need to update character parser and make sure that supports ES6 code. It turns out character parser is so tolerant of code that is malformed and not valid that character parser will just accept ES6 code anyway. I mean, character parser will accept C# code and probably mostly work. Constantinople's a little bit more advanced. You see that has to parse it using Acorn and then do the whole Acorn globals dance, but turns out Acorn supports ES6, so Constantinople supports ES6. With exactly the same scenario, we've got Acorn again, Acorn globals again. That all supports ES6, so that's winning as well. The function constructor that we use internally, where we call function with the string of JavaScript, in order to evaluate it. That depends on your environment. So if you're in IO.js, then you're going to have all of the ES6 goodies in there, and it should just work. If you're in an older version of Node, or if you're on the browser, then your function keyword, much like the rest of your environment, won't support ES6, so you're going to have problems there. So the next step, we use function in two places. We use it once to evaluate the code once we've generated all of it. We also use it inside the lecture and the parser to check that where you've typed things that should be JavaScript expressions, they're actually valid JavaScript expressions, so we can give you earlier and better error messages. So we need to change those to use Acorn, and then they'll support ES6 code, and that's half the battle run. And then the other thing we need to do is allow some kind of plugin step that lets you intercept the JavaScript code just before we pass it to function to evaluate it, and apply something like Babel, which was formerly known as 6-to-5, which is a transpiler that takes ES6 code and generates ES5 code. And if we allow you to do that, you can just start writing ES6 code straight away. And this shouldn't be too big a task once 2.0 is out. It should happen pretty quickly. So, how can you get involved? Well, we run a fairly similar open governance policy for Jade to JS transformers. It's a touch less open because Jade has rather more users, but it's still the case that if you contribute any significant change to Jade, you're likely to get commit access straight away. I tend only to give the ability to publish on NPM to people who have been regular contributors for a prolonged period of time. But if you submit code and it's good and we merge it, then expect to be given commit access to the repository. Here's a quick list of things you could consider doing. There's a guy in the room over there who has suggested that he'd like to write a jade linter. So go and chat with him if you want to get in on that. You can write your own fork, like React Jade and then Jade. Perhaps Angular is your thing and you think that Jade should generate slightly different code for Angular or accept slightly different input for Angular. Go ahead and do that. You can get in on the issue tracker. There's loads of people asking sometimes quite easy questions on the issue tracker, so go and answer them. And if you answer loads of questions, I'll end up giving you commit access so you can start closing the issues once they're done. Review pull requests. Docs are not 100% written. There are still a couple of undocumented features or poorly documented features. So go and flesh those out a bit if you know about Jade and you want to help out. If you're bilingual or trilingual or quadlingual, then have a go at translating some of the Jade documentation. We haven't. Well, all of them. So we have a Chinese version of the README, and I'd love to have more translations of the README. And I've been meaning to commit some time to make it easy to translate the website as well, but I haven't really got around to doing that. So pester me if you want to translate the Jade website. Then pester me, and I will get around to making that easier. I just wanted to have one quick plug while I'm here. The previous talk mentioned browserifying things and publishing a browserified version of your JavaScript library. If you check out brcdn.org, which is the browserified CDN, then you don't need to do this step as part of building your modules, because this hosts a browserified version of every module that is ever published to NPM. And you can just go there and upload it, and this website is also open source, so you can find it on my GitHub profile, and it's got loads of crazy fun science in it, because it uses Docker and all of that stuff to isolate the build so that no one can break the whole system. So check it out if you're interested in that kind of thing. Okay, any questions on any of that?
Questions?
That's what I've done.
So, going back to the lecture, you're saying that the Jade language compiler can parse HTML with regexes?
No. We're certainly not saying that. We're saying it uses regexes internally for some parts of the parsing. But in terms of its support for inline HTML, it's relatively limited. It doesn't parse the HTML. But it does recognize that if a line starts with open angle brackets, then the rest of that line is probably HTML, so it doesn't attempt to parse any of it as jade, and it simply outputs it in line with the template.
Had you considered using Antler or a peg, a parsing expression grammar?
I have looked at those. If I was starting Jade completely from scratch, I'd certainly consider that approach. I have looked at doing it so I've written a parsing expression grammar that attempts to parse regular expressions and produce an abstract syntax tree of those. I'd say starting with a description of the grammar that's in that form, I forgot the name of it, anyway, the right format, then that's relatively easy to write. But starting with a notion of how the language should behave, it's not that easy to do. And when I inherited the Jade project, we already had a let's from a parser written separately as JavaScript programs, and it doesn't really seem to make sense to make a shift. So if anything, it's easier to understand the lexer and the parser as they are written in JavaScript, and then modify those for new contributors.
Any other questions? He's got 7 questions.
I'll ask one.
That was one of my 7 questions. I mean, it's answered about sort of like how, whether you use regexes exclusively. I guess not. Thanks. Another question, which is just a bit stupid, really, but why is that one Constantinople model called Constantinople?
Well, because I thought constant, it's figuring out what things are constant, and I was looking for something that sounded a bit like constant, but was kind of snappy and easy to remember. And Constantinople, I thought, yeah, that's like constant, and then some other stuff on the end.
You know what I said earlier about the number of names?
Exactly, yeah,
That's a good one, isn't it?
I had a time machine. In like 5 minutes' time, I'm going to go back and tell my future self, come up with snappy, cool names, because someone said to do that.
Also, I just think it's a really great project as a demonstration of the power and the usefulness of having small modules that do specific things, but also some of the hiccups that come along with that and how to solve them. So I think it's really good. Good job and stuff. So thanks for your
Any more questions, though?
How many people? 2 more questions.
And the slides are online as well, slides.forbesl.co.uk or forbeslindsay.co.uk, and whatever.
Hiya. First time I played with Jade, I was playing with Bootstrap at the same time, and so it was a lot of kind of, here's some code snippets, I really want to kind of paste them in. And so I ended up kind of basically translating to Jade. I was just wondering, so 2 questions, do you have a tool that converts HTML snippets to Jade, which would be great, but then secondly, what's the kind of most requested feature for Jade?
Okay, so the first question then, do I have a tool that converts HTML to Jade?
On the homepage.
I don't. So the homepage has a tool that converts HTML to Jade, that converts Jade to HTML, as in you can just live edit the Jade and it produces HTML, which is kind of useful as a playground for when you're learning. I don't personally use any, I hand convert any HTML to Jade. But I'm aware that there are at least 2 projects that attempt to automate this.
There's Sublime plugin called HTML2J.
There we go. So yeah, there's a number of projects that are in this field that do this job. I think with varying degrees of success, and they vary in how well maintained they are. I thought about writing my own, but it's a non-trivial process, because you need to start with an HTML parser, and then you have the issue of the fact that Jade is white space sensitive and HTML is slightly white space sensitive, and the way that people write HTML tends to include a lot of white space that they don't really care about. So figuring out what white space matters and what white space doesn't is very tricky when converting into Jade in an automated fashion. I've got the second question. What's the second?
Most requested feature?
Oh, most requested feature. difficult. A lot of features that get requested get added fairly quickly, but I'd say there are two things that spring to mind as features that have been requested for a really long time and that we still don't have. One of them that gets requested again and again and again is people want some way to have the includes and extends be dynamic. So at the moment they happen at compile time, which means that they can't depend on the state of the locals or the state of the data you pass into the template. Trying to do them at render time when you have that information would be hugely inefficient. And trying to make that optimized is going to be a very tricky process. So there is some possibility for doing that by figuring out exactly which locals caused which paths to end up, and then you could perhaps cache the results. But it's a very complicated process to make in any way performant, which is why we haven't done it. I would say that hopefully the work that's going on currently to modularize the whole system that should separate out that loader and Lexer stage from everything else should make it possible for somebody, if they care enough, to implement this in user space as a separate kind of jade fork, and if it's good, then we can merge it. The other feature that gets requested fairly frequently is more advanced mixins. So mixins at the moment are fairly primitive, just kind of syntax sugar for functions. And often people are kind of like, whoa, this is so much more powerful than anything I had in HTML. It allows me to do so much more code reuse. And then they kind of push it and push it and push it, and eventually you get to some point where mixins just don't do that, they're just functions. So people request things like having multiple blocks defined inside a mixin, each with their own name. And then some people want to be able to pass a variable from inside a mixin to like the block that was created to call the mixin. And I think a lot of the features people request around there are really useful sounding features and not that difficult to implement in isolation. But figuring out the right combination of those features to implement to give everyone what they want, and then figuring out how you explain what this crazy, complicated beast is to newcomers is really tricky. And it's definitely an open question. There are open issues on the GitHub repository that are discussing this and saying, how can we do this? What are we going to end up with? And I think probably that doing that overhaul might miss the boat for Jade 2.0, so that'll be Jade 3.0 in 2 years' time, and hopefully with a totally different maintainer, because hopefully by then I will have stepped down, made my millions, and be tanning myself on a beach somewhere.
Is there anyone else who wants to ask a question? Obviously he knows a lot about Jade, so...
I'll be at the pub afterwards.
He's gonna be at
about 10, so you've got an hour and a half.
Any other questions about Jade that you'd never dare asking anyone? Awesome, I love it. Okay, well, thank you very much again. Okay. Well, that's pretty much it for tonight. Thanks for coming. If you have any node module that you want to advertise, you have 5 seconds to come on stage. Yes. 5 seconds.
I know I should have used this time before, but wait, it's more than 5 seconds, I don't care. Basically, I have this project which is called Forkability, and the purpose of it is to serve as a linter for your repository. It tells you what you need to add to your repository to make it a little bit nicer to fork. Very similar related to my talk, obviously. Here it is on GitHub. It's called Forkability. I'm looking for fun videos. Basically, anyone who knows any other language other than JavaScript would be useful. And there's also a really cool web interface for it.
Woo! Anyone else? Awesome. See you next month. Thank you.